right, today we're going to continue, we're going to go a little deeper on these reciprocal functions. But what do you notice is different about these equations? Look really quick at all of these equations. How do these differ from what we did yesterday? Yesterday they were in fractions. They looked like this, right? They looked like they were solved for y. They look like that. Or they look like this.
One variable. Oh, never mind, yeah. Both variables on the right same side of the equal sign.
These ones have y equal, these are what we did yesterday. Just to review really quick, what is the vertical asymptote? Where do you get that vertical asymptote? It's the number underneath right here. So x equals 0 is your vertical asymptote. What about the horizontal asymptote?
The last number.
It's that number right there. So for this one, what's the vertical asymptote?
-3.
No, vertical.
Oh, yeah.
X equals -1. What's your horizontal asymptote?
-3.
Good. How about this one? What's your vertical
0.
asymptote?
0.
And what's your horizontal asymptote?
4.
Okay, that's just what we did yesterday. But what's wrong with these equations today? Do you see them written in that same format?
Yep.
No.
Are they in that y equals?
No.
How am I going to get this equation? Now it's saying x times y.
Divided by x.
Very good. You are going to get y by itself. So you're going to divide both sides by x. So what is y equal to?
5/x.
Okay, so now let's review. How do you do the vertical asymptote?
Are they both 0? Because there's like.
They're both 0. Very good. And I'll put it there for you. So your vertical asymptote is the opposite of this number, but what's the opposite of 0? Just 0. And this one is going to be your horizontal asymptote. Now, do you remember what D, capital D, stands for? It's your domain. Your domain is all real numbers except x can't be 0. And your range is all real numbers except y can't be 0. Why? Why can't we have these numbers? Because you can't have 0 in the denominator of a fraction. So you will not have any points on these two lines. And you get them, those vertical and horizontal asymptotes, by these two numbers right there. Now, do you remember how to graph these points? See this 5 right here? It's a positive 5. So what two quadrants are we going to be in? Are we going to be in
First and third.
1 and 2, 3 and 4, 1 and 4,
First and third.
first and third? Can you tell me what points I want you to plot? If this is a 5, Andrew, what points am I going to plot?
Put 1, 5, 1 and 5.
1, 1, 2, 3, 4, 5. And where else?
5 and 1.
Yep. And what does it look like? A boomerang. And in the other quadrant, what's it going to be? -1, -5, 1, 2, 3, 4, 5. And -5, 1, 2, 3, 4, 5, and 1. -1. That's your graph. Now, are these two the only points? No, there's infinite points. How could, D'Angelo had asked, how do you get any other points? Well, give me an x value between greater than 1, we don't need 1 because we have 1, 5, and less than 5. So what x value is between 1 and, let's say, 4? How about 2? So if you had a table, and if I were to put a 2 in here for x, what is 5 divided by 2? 2.5. So here's another point. So if you went over 2, you would go up 2.5. So right there, so how off was I? Wasn't too bad, but if you want a better picture, because I'm noticing that some of you guys, when you connect these 2 dots, you're doing this. You're going like this. So you're a little bit more off. So how accurate you want to be is how much time and effort you put into, if you need a table, you can easily plug in. Every extra point besides these 2 will make your graph more and more accurate. Does that make sense? I could put a 3 in. I could put a 4 in. And you would see how it's curving. All right, let's try another one. What's wrong with number 2?
You can subtract 4 and then divide by it.
Very good. You're going to get y by itself. So we're going to subtract 4 and then divide by.
X.
So your equation is y equals -4 over x. You're going to notice on this worksheet, all of the vertical and horizontal asymptotes are.
Where'd you get negative from? Oh, minus.
When you bring 4 over, it becomes a
Yeah,
-4.
sorry.
So your vertical asymptotes on all of these are going to be x equals 0 and y equals 0. Just want to get you in the habit of writing this. Okay, what do I do next?
So left 1 and then up 4.
So first put in your asymptotes. I want to see these asymptotes on your graph. If you are not putting them in, please put them in. You're going to get points for the asymptotes. Now, where should I be? In what 2 quadrants?
I forget the number.
Come on, 1, 2,
2 and
3,
4.
4.
2 and 4.
2 and 4, good. Where do I go from here?
So left 1 and up 4.
And then 4, 1. -4, 1. Now, could I, if I connect these 2 dots, could I come up with another point in between here and here? Can you do it in your head? What point is it going to be? Right here. And how do you get that point right there? Well, if you plugged in -2 right here, what's -4 divided by -2? It's 2. Do you get this?
Yeah.
And please put arrows at the ends. This is indicating that it's getting closer and closer to these asymptotes. Now, did anybody have a graph? Did anyone get sloppy and go like that?
Blue.
Think of these orange lines. You can't cross them. You do not want to see any crossing over these x and y axes. All right, how about the next one?
Divide by 2.
Before you divide
Add
by
10.
2,
Add 10.
add 10. If you added 10 to 2, what do you get?
12.
You get 12. Then what?
6. Divided by 2 and 6.
Divide by 2. So you have x, y equals 6. Then what?
And divide by x.
Divide by x. So quickly, what's your vertical asymptote? 0.
0. 0.
0. ARN, x cannot be 0. ARN, y can, I want you to get in the habit of writing that out. Your asymptotes. What 2 quadrants are you going to be in?
4. Or other 1 and 3.
1 and 3. So over 1, up 1, 2, 3, 4, 5, 6.
How do I know that again?
Huh?
You just type that in the calculator?
No. If you were to think of a 1 here, if I were to put a 1 in here, Andrew, what's 6 divided by 1? 6. What about if I were to put a 6 here? 1, 2, 3, 4, 5, 6. You go up 1, because 6 over 6 is 1. Now, are you going to go like this? Are you going to go like this? How do you know from here to here, there's so many points, infinite points in between here? What if you want to make it perfect? Well, I would put a 2 in here. Why do you think I picked a 2? Because I know 6 divided by 2 is 3. And I'm going to put a 3 in here. Why 3? Because 6 divided by 3 is 2. So this graph right here, not the one underneath, is more accurate.
You put it at 3?
Because, think about it. If I put a 3 right here, what's 6 divided by 3? Look at a T-chart. If I plug a 2 in here or a 3, you should be able to do 6 divided by 2 and 6 divided by 3. So these two are 2 more good points. So this should mirror, we're going to have over 1, down 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 3. Okay, next one.
Add 12
Add 12, divide
divided by 3.
by 3, what do you get?
And divide by x and then y equals 4 for x.
What's your asymptotes? Now, who's doing this? I'm pointing out some errors. Who did that? Nobody, right? No one did that, right?
Yep.
Because on your test, you're gonna lose a half point. I wanna see x equals 0. I wanna see y equals 0. And for your domain, all real numbers. X can't be 0. All real numbers, y can't be 0. So your table, or your graph, you don't need a table, you guys. So you should have your broken line. And in what 2 quadrants are you going to be in? 1 and 3. Now I know 1, 4, 4, 1. Do you know how to connect these two? Should I come way down here? Should I go through 1, 1? Number 1, you can't because it's not a function then. If you had a point here and a point here. But what other point do I know?
2.
2. 2 what? 2, 2.
2.
This is so easy.
Are these easy?
It's too easy.
Easy? Now, if you can use your calculator, but isn't it easier to do it by hand like this? To me, it's too much, it takes too much time typing it in your calculator. And the cool thing is you used your brain. You did. Okay, who wants to help me with number 5?
You just do myself.
What do you do on this one?
Add 4.
Add 4. What do you get when you add 4 to 5?
9.
And then you're going to divide by?
3.
So you get x, y equals 3. What's y equal to?
3 over x.
Tell me what to write here.
0, y equals 0, and x equals 0.
Okay, what does your graph look like?
Asymptotes on the actual graphs. 1 and 3 also.
1 and 3, 3 and 1. Now what if I wanted to put a number in between here, like 2? It'd be 3 over 2. which is next one.
Minus 21. Oh, sorry. Thought you meant like next.
Okay, yep, go ahead, next one.
Minus 21.
Minus 21, then what?
5 by 7.
Divide by 7. What do you get?
-3.
Good. And then what?
Y equals -3 over x.
Okay, so what do you know about this one?
It's gonna be, on 2 and 4.
It's in 2 and 4. You're in 2 and 4. Good? 2 more. What do you do here? Get rid of what first?
Add the 23 to the.
You're gonna add 23 to what?
2.
Well, what is 2 plus 23?
25.
Then what?
5
Divided by 5, and then what?
Y equals 5 over x.
So what do you have?
Equals 0, y equals 0.
What quadrants are you in?
1 and 3.
1 and 3. So you're gonna go over 1, up 1, 2, 3, 4, 5. And the last one. What should we do first? Okay, so what's 20 minus 12?
8.
Then what?
5 by 2.
Divide by 2.
Y equals 4 over x.
Y equals 1 over x. Oh.
What quadrants are we in?
One and 3.
Okay. Thumbs up if you understand this and you're good. Okay, see a thumbs up from everyone. What do you think, Mr. Dewar? You think you got it? All right, just for fun,
Yeah.
just for fun,
Shut up, Jimmer Craig. What is it about Jimmer Craig?
how do you see how much you remember from yesterday?
Whatever.
How do you graph this one?
The vertical asymptote is plus 2.
X equals what?
Plus 2. Well,
And
yeah,
then
2. Then y equals just the regular.
And y equals regular 2.
Yeah.
Okay, your domain,
Is
all real numbers, x
Can't be
can't be 2,
y cube.
all real numbers, y can't be 2. So where are my asymptotes?
2 and 2.
This is for you, Andrew. I'm doing this for you.
Yeah.
Where are my two asymptotes?
2.
2.
At 2
And then 2.
and at this 2. Are you with us?
Yeah.
Okay, now, do you see 4 new quadrants?
Yeah.
This is quadrant 1, this is 2, 3, and 4. Where are you gonna put those 2 boomerangs? In which 2 quadrants?
2 and 4.
2 and 4.
2 and 4. Now, where are you gonna go from here?
Where they intersect those lines.
Right there is the origin. You're gonna go over 1 and up 1, 2,
3.
3,
Over 3.
and over 1, 2, 3, and up 1. This is what we did yesterday. Did I pick up a calculator?
No.
No. Did you?
No.
No. Do we need to?
No.
No. 1, 2, 3, in here, in here. Now, if you don't believe me, go ahead and pick up a calculator and you will see those points. So we don't even need this.
Don't.
Okay, Travis, turn that off.
Okay.